Well, hello again. I just want to do a couple of examples of general solutions. We're going to work in green today before we do our review tomorrow. And so I want to do general solutions for cosine, sine, and tangent to make sure that you remember these. So let's just go ahead and get started so we can get this done. I would like to find general solutions, which means that we are going to have to find all the solutions, and we're going to have to do those things like add 2 pi n or add pi n. I want to go back over those rules again. So let's start with an example of cosine x is equal to 1 over the square root of 2. So what we're going to do is we're going to draw our triangle. That's just so bad. At some point I'm going to be able to draw straighter lines than that. And we're going to draw it, since this is positive, we're going to put it here in quadrant 1. And then we'll put our angle x here. And then cosine is adjacent over hypotenuse. And so this other side is a 1. And so this angle that we're dealing with here is 45 degrees, or pi over 4. I'll just do degrees since most of us like that better anyway. So my solution here, this is called the principal inverse value, is 45 degrees. And what we do is we add 360 in. This is all the extra periods you want to, if you want to go around the full 360 or go around 720 or 1080, you just keep adding 360 to get there. That's the first solution. For cosine, the other solution is just the negative of that one. So for cosine, you find the principal inverse value, you add 360 in, and then your other equation is x equals the negative of what you found. So let's do sine. So let's have an equation, sine of x equals negative square root of 3 over 2. Not any better there. Sine of x is negative, so I'm going to put that down here in quadrant 4. And sine is opposite over hypotenuse. The adjacent side would be a 1, and so my reference angle here is 60 degrees. Since the reference angle is 60, because it's across from the square root of 3. And now I need to look and see what this angle of rotation is. That angle of rotation is negative 60. And then we're going to do plus 360 in to get all of those multiples. But now for sine, we have to find the other answer. The other answer is pi minus this principal inverse value, or 180 minus this principal inverse value. Since we're in degrees, mine's going to be 180 minus this answer, which is going to be 240, which by the way happens to be this other triangle in quadrant 3 where sine is also negative. So my other answer for sine is 240 plus 360 in. So for sine, you find your principal inverse value, add 360 in. The other answer is pi minus the principal inverse value, or since we're in degrees, it's 180 minus that principal inverse value. Okay, and then we're going to do a tangent example. So tangent equals the square root of 3. So we'll go here and draw a picture. We'll put it in quadrant 1 because it's positive. Put a 1 underneath that, so tangent is opposite over adjacent, and the hypotenuse is a 2. This angle is a 60-degree angle. And so your answer is 60 plus 180 in. Tangent and cotangent have a period of 180, so you just add 180 in, which gives you all of the answers, and you only need one equation for tangent. And that is all of those. I just have one extra thing I want to add, because today in class I saw this a bunch, and this is just an algebraic thing. And some of you think that m plus 2 squared is equal to m squared plus 4. And this makes me sad. This is not true. If you think this, you could plug numbers in to figure out, like 3 plus 2 squared. Does this equal 3 squared plus 2 squared? Well, you can see 3 plus 2 is 5. 5 squared is 25. 3 squared is 9 and 2 squared. What's going on here? They're not equal. That's because that was wrong. You cannot do that. Makes me see sad panda crying. Tear. Okay, anyway, m plus 2 squared means m plus 2 times m plus 2, and you have to FOIL this, box it, whatever. This is m squared plus 2m plus 2m plus 4, and this answer is m squared plus 4m plus 4. Don't make your algebra, well, your pre-cal teacher cry because of your algebra mistakes like that. This is not a true statement. One last thing before I let you go. For almost the same reason, the square root of 9 minus 4 does not equal 3 minus 2. You can't do that. You can't just take the square root of 9 and the square root of 4. Okay, I'm done. I love you all, but I'm sad panda sometimes.